Okay, so problems 1 and 2, as you can see, they're very similar. So I'm not going to go into too much detail with this particular problem. You have to reanalyze all the forces due to the external, reanalyze the system, ignore P for now. Find out what the internal forces due to the 150 kilonewton forces are. And once you have that, apply virtual displacement at E in the vertical direction to solve for the vertical deflection at E. Once you have that, you need to find out what the deflection at A is due to these vertical forces. So that's to find out the second part of the question. So your first part of the question, you're just going to analyze this, find the deflection at E. Second part, you're going to apply a virtual force at at A. Reanalyze that. That'll give you your. So you're going to do your table, right? This is going to be for. This is your delta E table. You're going to generate another table. And this will be for delta A, AY. This is just due to the external forces. Right, so in both cases, your P system will be this, right? This will be your P system for these two parts. The third part, or not third part, I guess, but the way to analyze, the way to find that force P required to make the deflection there 0 is to then analyze. So let's call this your P1 system. I'm going to apply a force here of P and find out what my deflection in the CY direction is due to this force P. So you're kind of using superposition here. I'm looking at the original 150 kilonewton loads. I'm applying that on my truss. I'm seeing what my deflection at this point is going to be. So my Q system for delta AY is going to be the same in both these cases, right? I'm just trying to find the deflection at that point. You'll notice that these two will be exactly the same, right? Except this one will have an extra product of P, right? I have the only force acting on this P system is a unit load is a point load at CY. The only force acting in this system is a unit load at CY. Therefore, everything that I get from this system, you'll just multiply by P. So if I get, for example, 0.707, then I would multiply that by P in this system. So for example, if my force, and I'm going to just use makeup of force, if my force FG, or for example, my force FG, if that was equal to 0.707 in my Q system, my P system would be equal to 0.707 P. I'll get a delta AY1 and a delta AY2. I'll add those two together and I'll get 0. Note that I'm adding these two together. I'm not setting them equal to each other. Delta AY1, and this was an issue that we had to address in the pre-lab as well for lab 3. These two are not equal to each other. They are off by a sign. It doesn't matter as much here because it's just two cases. But for example, if we had to add more than two, if we had to add 3 of them together, we would not be able to say that one of them was equal to another one, was equal to a third one. You'd have to add all of them up together and set them equal to 0. So just be careful when you're saying this. This is true because we're using the same Q system, right? So if we're using the same Q system in both cases, that means that our positive sign convention is the same for both of these. Positive sign convention is the same for both of them. That means they have to be on the same side of the equal sign. It might be that one of them is negative, right? Let's say delta AY is equal to negative 0.5 P, for example, and delta AY2 is equal to 0.4 millimeters or something. Then I would bring one over to the other side, and then I would solve for P, and then I would get a positive result. But I still need to make sure that I keep them on the same side of the equal sign until I plug in my values. Otherwise, things will start getting very messy. This one will be in terms of p. This one you'll have some numerical value, but for the second system, you'll have some result in terms of p. You'll be able to solve this expression for p. Similar to how you solve for m in the pre-lab, you'll solve for p in this assignment. Solve for p, right? I applied an unknown force p in this situation. So that is everything for that problem. Let us know if you have any questions.